Okay, so very good day to everybody present here. Once again, we are back with data structures. In today's session, we'll discuss about sorting, which is nothing but arranging. Then we discuss about the problem of sorting and some various common sorting strategies. This is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, let me thank God for giving me this golden opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students and young researchers. In today's session, we'll have a short introduction to sorting and then we discuss about in place and not in place sorting. We also discuss about adaptive and non-adaptive sorting algorithm. Of course, we also discuss about the flow chart of the selection sort. And we discuss how selection sort works. We discuss about the selection sort approach and we have a C++ code for the implementation of selection sort. We also discuss the complexity analysis, the time complexity and space complexity of selection sort, and then we discuss about an example, the C++ program for merge sort on doubly linked list. I've given the open-ended project work. Please complete them at your best available time. You just got 1 week. Just 1 week to complete. Just 1 week to complete all your independent works, laboratory works, and open-ended project work. Okay, right. So please complete them, and at regular intervals, I'll be giving you some short videos to discuss the knowledge in our topics. So this is sorting. The meaning is actually arranging. Sorting means arranging. You are going to arrange the data in a particular format. Maybe you can arrange numbers, or maybe you can arrange names in a alphabetical order, maybe ascending order, or maybe descending order. Okay, so here the data searching can be made optimized to a higher level. So if maybe if you already arrange the data in the sorted manner. Okay, so sorting, you can represent data in many readable formats. Okay, maybe in that case of the telephone directory. Have you seen a telephone directory? Have you seen a telephone directory? Directory.
Yeah. We know about sorting.
Okay, so telephone directory, you will have names of all the important people, even the people who are nearby also. You can see. Okay, maybe the big companies, organizations, maybe even the telephone number of your president. Also, it will be there in the telephone directory.
Yeah.
So according to the name, you can arrange it. Okay, right. So even if you take in the case of the dictionary also has words. Maybe if you take the name of let us take in the case a word called animal. What do? Animal. A word called as animal in a dictionary. No. You are searching for a word called as animal in dictionary. Okay, so what you will do? You will search for A.
Yes.
Then you will search for N. And accordingly, if you see, you will find the word animal. So if the names are not in an arranged manner, so you cannot find the names. Only if it is arranged means you can easily find it out. Okay, so same thing happens with the sorting even. There are two types of sorting. One is in place sorting and then not in place sorting. So in the case of sorting algorithms, generally it will require some additional space for comparison and for temporary storage of few data elements. So if you take in the case of in place sorting, it does not require any extra space, and sorting is definitely said to happen in place. Okay, if it is happening in place means it is in place sorting, but it does not require any extra space. Okay, but if you take in the case of not in place sorting, it requires extra space which is equal to or maybe more than the elements being sorted. Okay, so this sorting uses equal or maybe more spaces, means it is called as not in place sorting. Okay, so merge sort is an example of not in place sorting, while bubble sort is an example of in place sorting. This is stable as well as non-stable sorting. So in a sorting algorithm, after sorting the contents or maybe after arranging the contents, if it does not change the sequence of the similar content, then it is called as stable sorting. For example, here if you see, the numbers are placed in a not in an ordered manner. Okay, But if you try to arrange it, here if you say see 26 and 26 one after the another, if it doesn't change, then it is called a stable sorting. But if it changes the similar content means, then you call it as a unstable sorting. Right. So here we have adaptive as well as non-adaptive algorithm. So if you take in the case of adaptive, we already have sorted elements, which means we already have elements which are arranged. So while sorting, if it has already some elements already arranged, then you need not have to reorder them. So this is adaptive algorithm. But if you take in the case of non-adaptive algorithm, it does not take into account the elements which are already sorted. Okay. So this is the case of the non-adaptive sorting algorithm. So this is selection sort, which is going to sort an array by repeatedly finding the minimum element. Okay. So from the elements which are not arranged, you're going to find the minimum element and put it in the beginning. Okay. So this is selection sort. So here we will have two subarrays. One subarray will be already arranged and another one is not arranged. So the not arranged, you have to arrange them and keep it in the arranged one. Okay. So this is the flow chart of the selection sort. We'll go with the start and then read the length of the array, and then you go with the array in the array. Okay, so you set the I equal to 0 and you check if I is less than n minus 1. Then within that, if it is yes, you set the minimum index to be I and you set the j equal to I plus 1. So within the inner loop, you will have if j is less than n. Again, if yes, then if array j is less than array of minimum index, then you set the minimum index to be equal to j and you post increment it. So j plus plus. And you go with the swapping of the array of minimum index and array of I. Then in the outer loop, you have I plus plus. Okay. And you print the sorted array. I will tell you with an example. You will understand things better.
Okay.
So this is an example. This is an example. Okay. So you'll have array 64, 25, 12, 22 and 11. It's a very easy example. Okay. So the first thing, you take the first element, which is 64. Okay. So 64 is stored in the first position. Okay. So here you will have the array size a of 0, a of 1, a of 2, a of 3 and a of 4. Okay. So what is the minimum value of here? 64, 25, 22, sorry, 12, 22, 11. What is the minimum value? 11. 11 is the minimum value. So 11 you keep it in the first. And 64 you take it here. Okay, swap it, that's all. Okay, so it becomes 11, 25, 12, 22, 64. Okay.
It's double search, right? Double search.
Same. Selection. Okay. So next you go to the second element, which is 25. Okay. So actually 11 is already arranged. Okay. So here, what is the minimum element? 25, 12, 22 and 64? 12. So 12 you interchange, swap. So 12 goes to 25, 25 comes to here. Okay. Now you go for the next one, which is the third. Okay. What is the third element? 25. Already 11 and 12 are arranged. So here what is the minimum element? 22. 22 goes here, 25 comes here. Okay. And 22, 25 and 64. Okay. So for this case, 25 and 64, which is the minimum? 25. So 25 remains in place and 64 remains in that place. That's all. Okay. So this is how selection sort works, and this is the resulting array 11, 12, 22, 25 and 64. So here in this approach, you initialize the minimum value or maybe the minimum index to the first location, which is location 0, and you traverse the array in order to find the minimum element in the array. And while traversing, you find if any element is smaller than the minimum index. If it is found, means you are going to swap both the values. Okay. Then what you do, you increment the minimum index to point to the next element and you repeat until the array is actually arranged. So this is a C++ program for implementation of selection sort. You'll have hash include bit/std c++.h using namespace std function. Then you swap the function for this void swap int xp star and int yp star. So you assign int temp equal to xp star and xp equal to yp and yp equal to temp. Okay. Then you go with the void selection sort int array int n. You go with the int I comma j minimum index and you move one by one the unsorted subarray. So for I equal to 0, I less than n minus 1, I plus plus. Find the minimum element in the unsorted array. So minimum index is equal to I. For j equal to I plus 1, j less than n, j plus plus. So this is actually the inner loop I am talking about. Okay. So you go with if array of j is less than array of minimum index. So minimum of index is equal to j, and you swap that element. So swap of array minimum index comma ampersand array of I, and you have to print the array. So void print array in array comma int size, and you go with int I. For I equal to 0, I less than size and I plus plus. Then you print the array of I. Okay. Then you go with the cout. Go with the driver program. So it is 64, 25, 22, I mean 12, 22 and 11. Then you go with the int n is equal to size of array slash the first position. So it is size of array of 0. Okay. Then you go with the selection sort. Okay. So it is array comma n, and you print the sorted array. So we go with the print array comma n, and you finally return 0. So maybe if you go with the output, this is what we have obtained. So 11, 12, 22, 25 and 16. You are doing the individual project?
Presentation.
Presentation.
I showed.
Ah, wait. What it is raining about? So we have a complexity analysis of selection sort. So whenever you take in the case of selection sort, it is order of n square. It is nothing but because we have two nested loops, one outer loop and one inner loop. So that is the reason we call it as nested loop, one loop inside another loop. Okay. So one loop in order to select the element of the array, so that is for order of n, and another loop to compare the element of each and every other array element. So for that we have order of n. So overall complexity would be order of n multiplied by order of n. So it is order of n multiplied by n, it is order of n square. And similarly the auxiliary space or maybe imaginary space, we have the order of 1 to be the maximum order. So it is the, yeah.
I use some function to just sort something, and I use it to about two next loops. First
Same.
loop inside
Another loop.
inside another loop. So 3 steps.
3. So same thing, we'll have a temporary variable in order to swap the both the values. Right. So this is normally a question: is selection sort algorithm stable? No, it is not stable. But definitely it can be made stable. And whether if it is in place, yes, of course, it is in place because it does not require extra space. Okay, just for comparison only, we need that space. Okay.
What does it mean not stable?
No, it is not stable means actually you have to sort it out because it is it is not in order. So if you go with the definition of stable sorting, here after sorting the contents, definitely it will change the sequence of the similar content. For example, here if you take in the case of this particular example, even after sorting, the position changes. 64, 25, 12, 22, 11. It is changing every now and then. So it is altering the content. So it is not stable. Okay. Also, it is in place because it is not requiring any extra space. And this is an example, merge sort for doubly linked list. Okay, so we will understand this particular example. We will write a function to sort this doubly linked list in the increasing order using merge sort. Okay, so you have this one. Okay, we start from here. We have several elements: 10, 8, 2, 4, and 2. Actually, what we have to do is you have to go in the reverse order: 2, 4, 8, and then 1, 0. So this is a C++ program for merge sort and doubly linked list. So you'll have hash include bits slash std c++.h. Okay, and then you have this one using namespace std function, class node. Then you have public data type in data, node next previous. The node split, you'll have node head. Then you have a function to merge the two linked list. So you have node merge, node first and node second. Then you have If the first linked list is actually empty, then you go over if for the first, then you return second. Then the second linked list, if the second linked list is empty, for example, if not of second, then you return first. Okay, and you pick the smaller value. If first data is less than second data, then you go with first next equal to merge of first next and second, and first next previous is equal to first. Then you assign the first previous equal to null and return first. Similarly, else case we repeat for the second, the same thing. So second next equal to merge of first and second next, second next previous equal to second, and second previous equal to null, and finally you return second. Similarly, you could do the merge sort. So node merge sort of node head. Then if not of head and not of head next, then you return the head. Then you have node second equal to split of head. Then you do the recursive function for left half as well as right half. So head is equal to merge sort of head, second is equal to merge sort of second. Okay, and you return the merge of head and second. Then you have a utility function to insert a new node. So void insert node star star head and in data, node star temp is equal to new node, and temp data equal to data. So this one you try to swap it out. So temp next is equal to temp previous equal to null, and if not of head, then this head you are assigning to the temporary value. Else case you can go with the temp next equal to the next state equal to head, and head previous is equal to temp, and this head is equal to temp. So everything we are swapping it up. After inserting this particular node, then you will go with the utility function to print the doubly linked list. So what you do, you traverse both in the forward direction as well as reverse direction. So you go with the void print node head, node temp is equal to head. So print, you go with forward traversal using next pointer. So while head see out, you are going to print with the head data, temp equal to head, and head is equal to head next. Similarly, you go with the printing like forward traversal, you go with backward traversal. Okay, using the previous pointer. So same thing, while head, here there you had while head, here you have while temp, see out temp data, and temp equal to temp previous. Okay, after doing this forward and backward direction, then you swap the two integers. So void swap int a and b, and int temp equal to a equal to b equal to temp. Okay, then what you do, you split this entire doubly linked list into two halves. Okay, so node split node of head, so node fast equal to head, slow equal to head, and while fast next ampersand fast next next, then fast equal to fast next next, and the slow equal to slow next. Okay, but the other case we will have the opposite order. So node temp equal to slow next, and slow next equal to null, and return temp. Finally, you have a driver program in main of void. Then you have this one node head equal to null, then you insert 5 24 3 30 and 10, and finally you will have head is equal to merge sort of head, and you print linked list after sorting. Okay, so you print the head and return 0. So if in the output, if you can see linked list after sorting, so for the forward traversal you will have in the ascending order 3 4 5 10 20 30, but in the backward traversal you will have reverse order 30 20 10 5 4 3. So for this also we will have time and space complexity. For example, in the case of selection sort we have order of n square, but here in the case of merge sort it is order of n log n. Okay, and the space complexity maximum order of 1. Okay, here we are not using any extra space, just constant amount we are going to use. Finish your open-ended project work